Right. So we have discussed some questions again. So let us quickly deal with the other set of questions as well. Okay. So yesterday we were doing some questions, guys. I think around 20 odd questions we have discussed, I guess. The rest of the questions of electrostatics let us complete today. And let me know the timings for tomorrow, guys. Huh? If it is possible, morning, I think for some of them it is not possible. It may be possible in the afternoon. So let me know if I should take the class in the afternoon or should I continue at the same time. Okay, you can just tell that in the group at a latest time. Maybe by tomorrow morning you can inform, guys. Right. So we have discussed some questions related to electric charges and fields as well as potential and capacitance. Some more questions are left out. We will discuss those also. If possible, we'll start current electricity, guys. चलेगा अरे भाई is the board visible, all of you?
Yes.
Yes, sir.
Right. So we have discussed some set of questions yesterday, right? So there were little bit uh, moderate questions only. There were I don't think we have seen any difficult question yesterday, guys. Majority of the questions were easy to moderate itself, right? So let us see the rest of the questions. So one of this question was good question, guys. Again, okay, which is also there in your packages also, I believe. Right, in the same manner, we did some questions which were direct questions. This was again important question. I have not done the differentiation part of it, guys, right? But you will get it as a by 2 root 2. Okay, if you do and solve df by dx as 0, you will get it as a by 2. That is one of the good question again. Okay, then so I think, yeah, this was also one of 2r by 3 also is one of the good question. So till where did we do? कहाँ पे है भाई? So good amount of questions only we have solved, guys. Right. I think we have done till this question, dipole moment calculation. So let us focus on the other questions. Okay. I am sorry to join late. I was in travel, so I couldn't come on time. I hope you will understand. So we'll just discuss whatever questions are left out. We'll quickly complete them, guys. A thin metallic spherical shell contains a charge Q on it. A point charge small q is placed at the center of the shell, and a charge minus q1 is placed outside it, as shown in the figure. The force on the charge at the center due to the shell, they are asking. Due to the shell, what will be the force, guys? Can you please tell? Due to the shell. See, it is metallic shell, conductor. Even if you take simply spherical shell also, what is the field inside the shell? field inside the shell, because of this capital Q charge, the field inside will be 0. So will capital Q exert any force on the charge placed at center? No, guys, it is not going to exert any force. So 0 will be the answer. If they are asking total force exerted or force experienced by Q charge, the force experienced by Q charge will be force due to capital Q as well as force due to minus Q1. Here they are asking us to find only force due to capital Q. So capital Q is a shell. Inside the shell, field will be 0. So force also will be 0. So this will be 0, guys. However, will Q charge experience any force? Yes, it will be experiencing a force due to minus Q1. And due to minus Q1, where will the force be? Because it will be attraction, it will be towards left. So net force will be towards the left, guys. However, force on the charge at the center due to the shell will be 0 again. Clear, all of you? Direct question again. Yes or no?
Yes, sir.
Let us move on to the next question again. Let us see this question, guys. In a certain region of space, electric field is along z direction throughout. The whole field is along z direction. The magnitude of electric field is, however, not constant, but increases uniformly along positive x direction. So which type of field it is? Is it a uniform field or non-uniform field, guys? See, it is unidirectional, but the magnitude of the field is not constant, guys. They are saying that it is increasing uniformly along positive direction at a rate. So what is given? The rate at which electric field is increasing is given, guys. dE by dt value is given as 2 Newton per, I think, per meter. So dE by dx is given to us. See, Newton per coulomb is electric field. Here they have given Newton per coulomb meter, guys. So instead of writing dE by dx, it is better to write dE divided by dz. So dE by dz is 10 Newton per coulomb meter, guys. What they are asking, the force experienced by a dipole of dipole moment 0.2 into 10 power minus 5 coulomb meter in negative z direction they are asking. So there is a short dipole. Let us consider. So I'll assume this to be z direction, guys. Let us imagine this is z direction. So is it a non-uniform field or not? Yes, it is a non-uniform field. So I have told you what is the force experienced by the dipole plays in non-uniform field, guys. They are saying that the dipole moment is along negative z direction. So in general, what is the force experienced? See, dipole moment is like this, means what we can tell? Here you will have negative charge. Here you will have positive charge. So please try to understand. See, I'm just showing it in this manner, guys. This is our dipole moment. So here you are going to have which charge? Negative charge. Here you will have positive charge. Let us say this is placed at z is equal to 0, and let us play this is placed at z is equal to dz, guys. Okay. So where is strength more? It's clearly mentioned that the strength is going on increasing. Yes or no? So hey, where is the electric field? It is directed along positive z direction. Dipole moment is along negative z direction. Always remember, whenever a positive charge is placed in the field, it is going to experience a force in the direction of field. So here it will experience a force Q into some E, let us consider. Whereas the strength here is more or not, guys? The strength here is more. It is a negative charge. Whenever negative charge is placed in an external field, it will experience a force opposite to the direction of field. And what will be the force here? Here you are going to get it as Q into E plus dE. Okay. Why? Because they have clearly mentioned it is increasing uniformly along positive x direction. Okay. So what is the net force experience? Can you please tell? The net force experience will be, can I write it as Q into E plus dE along negative z minus QE. Overall, where will the net force acting? It will be along minus K cap, guys. So I'll get it as Q into dE along minus K cap. Clear, all of you? This is the net force experience. Is charge given to us? No. What is given to us? Dipole moment is given. So how can we write dipole moment? Here it is mentioned as P, let us say. How can we write dipole moment, beta? P can be written as magnitude of charge times of what is separation between them? Dz. So what we can write Q value as? I can write Q value as P divided by dz into dE minus K cap, you can write. It's a very important question, guys. So I can write it as P into dE by dz minus K cap. So where will the net force be? It will be along negative z direction. As you can see, there is only one option stating negative z direction, so you can directly write that. So how much is p value beta? 0.2 into how much is p value here? क्या हो गया इसको? तो p value is अरे 0.2 into 10 power minus 5 kilometer. What is dE by dx given as 10? So how much will you get the answer as beta? 2 into 10 power minus 4 you are going to get. Did I do any mistake? 10 power 6 I think it is given as. I wrote it as 10 only. It is given as 10 power 6 guys. So what are we going to get? You will get it as 2 Newton along minus k cap. Clear everyone? Did I tell you this or not? The net force experienced by the dipole placed in non-uniform field. What is it given as? P into dE divided by dr. So the answer should be 2 Newton along negative z direction. Understood? Did you understand all of you? See, again, what is the same concept? Whenever a positive charge, based on this motion of a charged particle, many questions have been asked in previous years, guys. Whenever a positive charge is placed in an external field, it will experience force in the direction of field. Whenever negative charge is placed in an external field, it will experience a force opposite to the direction of field. And they have mentioned that dipole moment is along negative z direction. Dipole moment, as you know, it will always be directed from negative charge to positive charge. So negative charge is here, positive charge is here. So I can consider that more force will act on negative charge than positive charge. Clear everyone? Are yes or no, Ray?
Yes, sir.
Let us try to understand next question. A similar kind of question was asked in NEET 2021, guys, related to capacitors again, effective capacitance they have asked. Right, similar kind of question was given, to be honest. This C and this C were not given, I think, or maybe one C, some C was given, this C was not given, guys. Equivalent capacitance of a combination shown in the figure between points A and B, they are asking. So whenever they are asking you to find this, very easy question. Let us say potential here is VA. Okay, here what is potential? VA. Between this point and this point, is there any element? No. So potential will be same. Between this point and this point, is there any element? No. So potential will be same. Between this point and this point, is there any element? No. So potential will be same. Between this point and this point, is there any element? No. Between this point and this point, is there any element? No. So what is the potential here? Can I say it is VA? What is the potential here? Here VA. What is potential difference across this capacitor beta? One end is VA, other end is also VA. Potential difference is zero or not? Because the potential difference is zero, what we can do this, there will be no use of this capacitor. You will remove this capacitor, guys. Clear everyone? In the same manner, let us say potential here is VB. Let us say potential here is how much beta? VB. Between here and here, no element, so same potential. Between here and here, no element, same potential. Between here and here, no element, same potential. Here also you'll get VB. Same manner, between here and here, no element, same potential. Between here and here, no element, same potential. So what will I get here? VB. Now you see this capacitor C, guys. What is the potential difference across the ends? Again, zero. So there is no potential difference, means there will not be any use of this capacitor. So we will remove this capacitor, guys. So what is the effective situation now? This capacitor is across a potential difference VAB. This capacitor also across potential difference VAB. This capacitor also across potential difference VAB. So I am going to get a combination something like this beta. I am going to get a combination something in this manner. Okay, this capacitance is C, another also is C, one more is 2C, guys. So what is the effective capacitance between A and B? All these three are in parallel or not? So what will be C effective? It will be C plus 2C, which you will get it as 4C. Clear? अरे अर्थమైందా? Hello.
Yes, sir.
Right, it's a very good question. Always remember, the use of a capacitor is to store charge, and charge can be stored only when there is potential difference. So if across the capacitor, if there is no potential difference, there will not be any use of that capacitor. We will simply remove that capacitor, guys. Understood? I hope you all have understood it, guys. Okay, let us talk about the next question. A spherical volume of radius 10 centimeter contains a uniformly distributed charge of density 2 into 10 power minus 4. Okay, so dq by what is given to us? Charge per unit volume is given. Electric field at a point inside the volume at a distance 5 centimeters from the center. See, again, very important case, guys. If I talk about a uniformly distributed non-conducting uniformly distributed. Please write these values again, guys. Non-conducting solid sphere. If I take a uniformly distributed non-conducting solid sphere whose charge is q and radius is r. So we are going to find at different points, guys. You can find the strength of electric field, you can find the uh, potential value and equipotential surfaces. And equipotential surfaces. Okay. Now, where are we going to find firstly? I am going to find inside. So inside means small r is the distance from center, guys. Small r will be less than capital R. So inside the field for a non-conducting uniformly distributed solid sphere will be given as kq divided by capital R cube small r beta. Kq divided by capital R cube small r. Potential is very important again. It is given as kq divided by 2 capital R cube 3 capital R square minus small r square. And how will equipotential surfaces be? The equipotential surfaces are going to be spherical. In the same manner, I want to find on the surface. So on the surface, small r will be exactly equal to capital R, guys. So here field will be kq divided by capital R square. Potential will be kq divided by r. At surface, we are not going to define equipotential surfaces, guys. Same manner, I want to find outside. See, whenever a point is outside the solid sphere or spherical shell, we can concentrate the whole charge at the center, guys. So it will be same as that of point mass, point charge, kq by r square. Here you will get kq divided by r. And what will be the equipotential surface? Again, you will get spherical equipotential surfaces only. In the same manner, so inside we have done, surface we have done, outside we have done. Let us find out at the center. At the center, smaller value will be 0. So center is lying inside. So if smaller value is 0, field at the center will be 0. Potential will be 3 by 2 kq divided by r. And will not be defining equipotential surfaces here. So it is very important to note that the potential at center will be 3 by 2 times the potential at surface in case of a uniformly distributed non-conducting solid sphere. So what are they asking us to find? They are asking us to find what is the electric field at a distance 5 centimeters from center, radius is 10 centimeters, rho value is given to us, guys. Density per charge per unit volume is given to us 2 into 10 power minus 4. So what is the electric field inside? Because small r is less than capital R, it is inside. So what we can write, beta? It is kq divided by, so I can also write it as rho r divided by 3 epsilon naught. How? I'll tell you. K value, as you all know, it is 1 by 4 pi epsilon naught q divided by capital R cube into small r. Yes or no? What I'll do is I'll multiply and divide by 3. Are we making any change? No, we are not making any change. Now what I'll do, I'll just rearrange them, guys. I can write it as 1 by 3. Oh, sorry. Yeah, 1 by 3 you can write. Q divided by, I can write it as 4 by 3 pi r cube. Here I'll write 1 by 3 epsilon naught, guys. I'm just slightly making a change here. Okay, and into small r we'll write. What is this? Is it charge stored per unit volume or not? Charge stored per unit volume is volume charge density beta. So I'll get it as rho r divided by 3 epsilon naught. That would be the electric field at the point inside the non-conducting solid sphere, uniformly distributed solid sphere. So what we can write, rho value is given as how much beta? 2 into 10 power minus 4. Distance is given as 5 centimeters. So I can write 5 into 10 power minus 2 divided by 3 into, what is epsilon naught value? As you all know, epsilon naught value will be 8.85 into 10 power minus 12. So 2 5s are 10 you will get again. This will be near about 10 power 5, guys, 10 power minus 5. If I send this to numerator, you will get it as 10 power 7 divided by 3 8s are 24. If I take approximately 9, guys, you will get it as somewhere around 27 you will get. So 100 divided by 27 into 10 power 5. Okay, which is 3 point something. 3.75 into 10 power 5 will be the answer. Clear, all of you? Did you understand, everyone? Yes or
Yes,
no,
sir.
yaar? Right? It's a very good question again. Please remember, for non-conducting uniformly distributed solid sphere, these will be the variations, guys. Inside, outside, surface, as well as at the center. Clear? Understood, all of you? Also, please remember what is electric field. Electric field inside can also be given as rho r divided by 3 epsilon naught. Rho is volume charge density beta. What is rho called as? Rho will be called as volume charge density, which is charge stored per unit volume. R is the small r is the distance from the center. Okay, 3 epsilon naught anyhow we can write. Understood everyone? Dielectric strength of a dielectric. What is it they are asking, guys? Basically, dielectric strength is something called as electric field, guys. Okay, so maximum potential which a dielectric can bear without breakdown. Is this correct? Dielectric strength? No, guys, it is not correct. The maximum value of electric field which a dielectric can bear without breakdown. This will be correct, guys. Okay. Maximum charge which a dielectric can bear without breakdown is wrong again. So dielectric strength of a dielectric or any material, dielectric strength of a material will be the maximum value of electric field which it can bear. Okay. Understood everyone? Please remember that dielectric strength will always be electric field value, not potential, not charge. Okay. Right. If we look at the next question, देखो भाई, 5 capacitors are connected. Circuit as shown. The charge stored on 4 microfarad capacitor they are asking. On which capacitor? 4 microfarad capacitor they are asking, guys. Okay. So for that purpose, what I'll do is firstly, we need to frame it in a proper manner again. So if you see, whatever is potential here, I'll take this point as 1, guys. Whatever is potential here, same will be potential here. Yes or no? Because between this point and this point, there is no element. In the same manner, whatever is potential here, same will be potential here or not? Yes or no, everyone? Arey हाँ या ना यार. See, whatever is potential here, between this point and this point, there is no element. So here also you'll have same potential. Whatever is potential here, between this point and this point, there is no element. Same will be potential here. So if you look at 6 microfarad, 4 microfarad, 8 microfarad, the potential difference across these three capacitors is the same or not, guys? 1 2 1 2 and 1 2 only. Yes or no? The potential difference across these three are same. So 6 4 and 8 will be in which combination? Parallel combination. So these all three, if I take this three, if I take, guys, they are going to be in which combination? They are going to be in parallel combination. So this will be which combination, beta? Parallel combination. So what will we see value for if I replace with all of these with one capacitor? What will it be? I'll get C dash, let us say. So what will that C dash value be, beta? It will be 6 plus 4 plus 8. So C dash will be again how much, beta? 18 microfarad or not? So what I can say now, the whole circuit will now become 118 is all can be replaced with 18. Again you have 18. So three identical resistors are connected in series, beta. Now in this situation, this is 30 volt. This is 18 microfarad. This is also 18 microfarad. This also happens to be 18 microfarad. So whenever three capacitors are connected in series, identical capacitors are connected in series. So what will be the effective capacitance of these three? These three are connected in series. So what will their effective capacitance be? If you talk about the effective capacitance, the effective capacitance will be 18 divided by 3, which turns out to be 6 microfarad, guys. Okay, so they're asking us to find the charge stored on 4 micro. Again, it is very, very important. Charge stored on 4 microfarad capacitor they're asking, and potential drop across 4 microfarad they're asking. It is very important case, guys. Now, the total potential difference we got 30 volts. Yes or no? So what we can do, I can just take this as total charge. If I want to find, it will be given as C effective into V, which is 6 into 30. So total charge stored will be how much, beta? You'll get it as 180 microcoulomb. Is this clear? Now you please tell me, all these are 18 microfarad only, no? Are all these 18 microfarad or not? Yes, so because they have identical capacitors again. Now please try to understand, 30 volts will get distributed equally. Across this, you are going to have 10 volts. Across this, you are going to have 10 volts. Across this also, you are going to have 10 volts. Now, if you look at this situation, this is 18 microfarad, guys. Now, how did I get this 18 microfarad? Is it a combination of 6 microfarad, 4 microfarad, as well as 8 microfarad in parallel or not? अरे हाँ या ना भाई? Yes or no यार?
Yes, sir.
This is your 30 volt. This is anyhow 18 microfarad. This overall we got again 18 only. This is also 18. So will this 30 volt get equally divided or not? And how much is the charge stored, guys? The charge passing is 180 microcoulomb. Okay. Now you see what is the potential difference. Easily we can tell this, guys. So between these 2 points, how much should the potential difference be? Between these 2 points, it will get equally divided, 10 volts. Similarly, between these 2 points also again 10 volts. Between these 2 points also again 10 volts. Right. So this is 6 microfarad, 4, and we can tell 8 microfarad. Or what I'll do is, guys, instead of writing like this, I'll take 4 alone, 4 I'll take separately. 6 and 8 will be in parallel only again. 6, 4, and 8 are in parallel. So what I'll do, I'll take 6 and 8. 6 and 8, what is effective capacitance? Will I get 14 microfarad or not? And here you have 4 microfarad. So they're asking us what is the potential difference across 4 microfarad. So what will be potential difference across 4 microfarad? It will again be how much beta? 10 volt only. So as you can see, which is there 10 volt? Only one option is there. You will get 40 microcoulomb. How you are getting 40? I'll tell you guys. So total charge flowing is 180 microcoulomb. Yes or no? So till here also total charge Q will be flowing. Now what I am saying is this charge is going to get divided. So here you will have Q1. Here you are going to have Q2. Are they both connected? 14 and 4 are connected in parallel or not? So in parallel combination, what should remain same? Potential difference should remain same. And how will charge get divided, beta? Q1 by Q2 will be C1 divided in the ratio of their capacities. They're asking us to find Q1 value. What will I get Q1 value? I'll get it as total charge into C1 divided by C1 plus C2. What is total charge? 180. What is C1? 4. What is C1 plus C2? 4 plus 14 you will get, which is 18. So 180 by 18 will be 10. 10 into 4 will be 40 microcoulomb. Is that clear? Did you understand? అరే హలో అర్థమైందా? 6, 4 and 8 will be in parallel combination. The effective capacitance of that will be 18. So I have taken 318 microfarad capacitors. Total potential difference is 30. So what would be the potential difference across each 18 microfarad? 10 volts, guys. Okay. So across this 10. Now this 18 microfarad, I can resolve it as two resistors. One will be effective combination of 6 and 8, which is 14, and other will be 4 microfarad alone, guys. So across 18 microfarad, you have 10 volt. Across 14 and 4, you will have 10 volt only. How much charge is given by the battery, guys? 180 microcoulomb charge is given by the battery. So that charge will now get divided in parallel combination. How will charge get divided? In the ratio of their in the ratio of their capacitors, guys. So Q1 value can be written as QC1 divided by C1 plus C2, which will get it as 40 microcoulomb. Clear, all of you? Is that clear, everyone? Am I audible? Hello? ఏ అందరు వెళ్ళి
Yes, sir.
నాకు కనిపిస్తలేవు భయ్, మీరు థమ్స్అప్ లేపుతారు కానీ థమ్స్అప్ దొరకలేదు, వాటరే ఉంది ప్రస్తుతానికి అయితే. Right. Next question. The flux through the hemispherical curved surface placed in uniform electric field in the figure shown. Okay. What is the flux through hemispherical curved surface? They're asking, guys. Let us try to find that out. So how many surfaces it has? Two surfaces. Yes or no? Is it a closed surface placed in uniform electric field? What should be the total flux? You please tell. Total flux should be 0. Total flux is 0 means flux with base surface as well as the flux with curved surface should be 0. Why did I write total flux as 0? Because we already have the statement again. Whenever a closed surface is placed in a uniform electric field, the total flux associated with it will be 0. Base, let us talk about. How is base placed, beta? Base is placed in xz plane. In which plane? Xz plane. Electric field is along x-axis. Base is placed in xz plane. So where will area of the base be, beta? Area vector of the base, as you can see, area vector will always be perpendicularly outward, beta. Yes or no? So for the base, area is along y-axis. Yes or no? Downward direction. Electric field is along x-axis. So what is the flux associated with base? Is it zero or not? Whenever electric field and area vector are perpendicular to each other, what is electric flux beta given as? It is given as E bar dot A bar for uniform electric field, which I can write it as E A cos theta. So for base, what is the angle between area vector and electric field? 90 degrees. So for with base it is zero. So automatically with the curved surface also, what will be the flux beta? The curved surface, with the curved surface also it is going to be zero. Understood? Yes or no?
Yes, sir.
I hope it is clear, guys. Right. Now what they have given in this question is some negative charge is uniformly distributed in a non-conducting sphere. Then its potential. See, guys, whenever you are trying to find potential or potential energy, however the charge is, you will take it as it is. So just now I have written some values. No, if you just look back, if you look back somewhere over here, I have taken all these for positive charges, guys. Right? So what will be for negative charge? In place of q, you will write minus q. As simple as that. So they're asking what is the situation for potential they are asking over here, guys. So let us try to see. Some negative charge is given. So what are the values for potentials? Now I'll get potential anywhere inside if you want to find. What will it be? Because it is negative charge. Minus kq by 2 capital R cube, 3 capital R square minus small r square. This is one. Similarly, what is potential on the surface? It will be minus kq divided by r. Okay, what is potential outside? Potential outside will be minus kq divided by small r. And what is potential at the center? Potential at the center will now be minus 3 by 2 kq by r, guys. Okay, so what would be the case now? Where is it minimum? Where is it? So if I plot the variation, right, because the charge is negative, you will also get potential as negative. If I plot the variation of this, guys, right, inside you will obtain a parabola, right, till surface. Then after that you are going to get a rectangular hyperbola. Clear, all of you? This will be the plot of the graph if it is a negative charge. If it is a positive charge, exactly reverse of it, guys. Okay, so what is this value over here? This value is small r equal to capital R. This value is small r is equal to 0. Here the value is minus kq divided by r. Here the value is minus 3 by 2 kq by r. So where is potential minimum? Is it minimum at r is equal to 0, which happens to be center, right? And where is it maximum? Somewhere at infinity, which happens to be 0. So what we can tell regarding here, the if it is a non-conducting sphere, potential will be minimum at center if it is negative charge. If it is positive charge, guys, potential will be maximum at center. Now when will it remain same throughout the material? It will remain same throughout the material if it is a conducting sphere. If it is a conducting sphere, electric field inside it will be 0. Potential everywhere will be constant. Clear? Yes or no? అరే అర్థమైందా లేదా? Acha, you people are throwing. Now you are not even throwing thumbs up.
Yes, sir.
That is what I'm saying. You're not even throwing thumbs up. Yes, sir. Let us see the next question, guys. A capacitor, again,
I mean,
very important concept, guys. This question has also been asked 2-3 times in NEET, right? 2018 it was asked, but after 2000, I think 2020 also it was asked, guys. Similar type of question again, right? So a capacitor of capacitance C is charged with a battery and energy stored in capacitor is U. So initially you have taken one capacitor, guys. Only one capacitor we have taken, and it is charged with the help of a battery. Okay. So what is going to happen? Capacitance will never depend on charge or potential difference. Let us say its capacitance is C. This plate is connected to positive charge, so it will positive higher potential. So this will plate will become positively charged. This plate will become negatively charged. Energy stored is U. What is the energy stored in the capacitor, beta? If C is the capacitance connected to V volts, in first case, what is the energy stored? You will get it as half C V square. Now, after disconnecting battery, another uncharged capacitor of same capacity is connected in parallel to the first. So now what is the situation you see? Now I have something like this. After it is completely fully charged, I am connecting it to an uncharged capacitor now, plus minus. So what is the initial potential of this? Initial potential difference of the first capacitor is V. What is the initial potential difference of the second capacitor? It is 0. Energy stored in each capacitor, now they are asking. What are they asking? Energy stored in each capacitor. So now can we find out common potential or not? What is the formula for common potential? It is C1 V1 plus C2 V2 divided by C1 plus C2. So as soon as you connect a charged capacitor with an uncharged capacitor, sharing of charge will take place until both of them are going to attain a common potential. So what will common potential be? C into first capacitor is charged to V, second capacitor is not charged, guys. It is uncharged, so it will not have any potential difference. Divided by C plus C you will get. The common potential will be CV divided by 2C, which turns out to be V by 2. Now this is our common potential. Now they are asking what is the energy stored in each capacitor now. So what is the energy stored? Let us say U dash is the energy stored. What will I get, beta? Half into in each capacitor. This is maintained across what potential difference? Vc square. So I'll write half into C into V by 2 whole square, which I'll get it as half into CV square divided by 4. I can also write it as 1 by 4 into half CV square. Half CV square is already equal to U. So what is the new energy stored in each capacitor, beta? It will be equal to U divided by 4. Clear all of you? Understood everyone? I hope it is clear, guys. Okay. Next, they are asking minimum number of 2 microfarad identical capacitors. Minimum number of 2 microfarad identical capacitors which can withstand a maximum potential difference of 40 volts required to design a circuit 400 volts, sorry, required to design a circuit of effective capacitance of 2 microfarad bearing voltage again 1000 volt, right? So what they're asking is each 2 microfarad capacitor can bear a potential difference of 400 volt. Suppose let us take, I have taken one capacitor here, we got 400. Let us take another capacitor here, 400. So this is maintained at 400, this is maintained at 400. Overall, I got 800 only. Yes or no? But I want 1000. So let us say we can take one more capacitor. Maximum it will become 1200, but I can get 1000 volts from this. Yes or no? Yes or no, yaar? Yes. The minimum number of 2 microfarad identical capacitors which can withstand a maximum potential difference of 400 volt. So each capacitor is withstanding 400 volt and I want effective capacitance to be how much, beta? 2 microfarad. Right. When will effective capacitance be 2 microfarad now? Minimum number they are asking, guys. So let us say these three are in series. If I want effective combination of these three to be, how much I should get? C effective value as? C effective value, they are saying we should get 2 microfarad. Let us say these three are identical, guys. So when will I get 2 microfarad? When each of these is 6 microfarad, 6 microfarad, and 6 microfarad. Will I get 2 microfarad, beta? Yes. Now, in order to get this as 6 microfarad, and in order to get this as 6 microfarad, I have only 2 microfarad capacitors. And in order to get this as 6 microfarad, what should I do? Here, shall I place 3 2 microfarad capacitors or not? Are you getting my point, guys? Here I will place 3 2 microfarad capacitors. Yes or no? Again, here also I will place 3 2 microfarad capacitors. I'm just going in reverse manner, guys, to solve this question. Again, here also I'm going to place 3 2 microfarad capacitors. What is the potential difference across? Maximum potential difference is 400 volt. Yes or no? So across these two, I can say 400. Across these two, I can say 400. Across these two, I can say 200 only. Maximum it can bear is 400. Up to 400 it can bear. It can bear less also, guys. So here we will have a potential difference of 400 volt. Here also 400 volt. Here you can say 200 volt. Right? I want effective capacitance as 2 microfarad. It means I need to have 3 6 microfarad capacitors. How will I obtain 6 microfarad capacitor here? By placing 3 2 microfarad capacitors. Yes or no? 3 2 microfarad capacitors. If I am placing, I am going to get the effective capacitance as well as the effective potential difference beta. Yes or no, all of you? Now please see, in this row how many capacitors? 3. Here also how many capacitors? 3. Here also how many capacitors? 3. So overall how many capacitors do we require, guys? The minimum number of 2 microfarad capacitors that can withstand a maximum of 400 volts required will be 9 in order to obtain an effective potential difference of 1000 volts and effective capacitance of 2 microfarad. Clear, all of you? First go with potential difference. First you try to ensure that the criteria of potential difference is first fulfilled, guys. I want a potential difference of 1000 volt. So what I need to have? 400, 400 and 200. Okay, clear, all of you? And I want effective capacitance as 2 microfarad. So I have taken 3 terminals again and I want 2 microfarad. So each should be 6 microfarad. When will each be 6 microfarad? When in each terminal or each capacitor, should have 3 2 microfarad capacitors placed in parallel. Understood, all of you? Understood?
Yes, sir.
Yes, sir.
Again, very good question. It is NCRT based question only, guys. Next, a soap bubble has radius 1 meter, it seems, is charged to a potential of 100 volts. Its radius is then doubled, it seems. The electric field at the surface of the bubble now will be how much they are asking. So what is the value of potential? Can you please tell? Potential value we know for a soap bubble, guys. Soap bubble is nothing but spherical shell. Yes or no, guys? Soap bubble will be in the form of a shell again. So what is the potential on the shell, guys? KQ divided by R is the potential. Now what they are saying, what is the electric field at the surface? And what is the electric field at the surface? It is KQ divided by R square. They are asking us the electric field at the surface of the bubble will now be when its radius is doubled. So what would be the new radius here? The new electric field will be KQ divided by R dash square, which I can write it as KQ divided by 2R whole square, which I will get it as KQ divided by 4R square. Now please tell me, we know already potential is KQ by R, actual potential. So from this, can I write it as the new electric field will be KQ by R can be written as V. Can I write it as V divided by 4R beta? So 100 divided by 4 into 1. The electric field will get it as 25 volt per meter. Clear? समझ में आया? Hello, अर्धమైंदा?
Yes,
On the
sir.
Yes, sir.
surface of the shell, potential is KQ by R. Right? On the surface of the shell, field is KQ by R square. They are asking when radius is doubled, what is the field? So if radius is doubled, the field at the surface will become KQ by 4R square. So I can write it as V by 4R. Already V is given, R is given. You can find the electric field, guys. Understood, all of you? Next question, let us see. What they have given, A and B are two concentric spheres. A is given a charge Q and B is earth. Then what is the situation they're asking? B is earthed, guys. What is B? B is earthed. B is earthed means what should be potential at B? Potential at B should be 0. Concentric spheres they have given. Obviously inside there will not be any. We have done similar kind of question again, guys. Right? The electric field inside and outside A is 0, it seems. Now, firstly, potential at B should be 0. Yes or no? Because it is earthed. But if you find potential at B, guys, it will be due to A and it will be due to B. Yes or no, all of you? So I can write potential at B should be equal to 0. Why should it be equal to 0? Because it is earthed, guys. So let us imagine this is our first sphere. Let us take this is our second sphere. So what potential will follow principle of superposition? Potential at any point should be Algebraic sum of potentials due to all the charges present in the system. So potential due to first sphere as well as potential due to second sphere at point B should be how much beta? 0. What is potential due to first sphere? It has some charge. Let us say it has been given, it is mentioned that it is given a charge q. Is this point outside the shell? Yes. So whenever a point is outside the shell, we can concentrate the whole charge at the center, guys. Okay. So let us imagine one of them has radius r1, other has radius r2. Okay. Now please tell me, I can concentrate the whole charge of A at the center because the point of consideration is external to the sphere by shell theorem, guys. So what will be potential due to 1? It will be kq divided by r1 plus potential due to 2 should also be there in order to make it 0 beta. So what is potential due to 2 beta? It should be minus of kq divided by r1. So I don't know what is the charge on it. Okay, so let us imagine the charge on B, let us say is q beta. Okay, so what will I get? Again, I have done this question yesterday only. If you people remember, we took a Gaussian surface just inside, guys. So I got, if positive charge is given here, what should be the charge on the inner surface? It should be minus q again. Yes or no? You remember it or not, all of you? Are you remember it or not? I hope so. What they have given, electric field inside and outside B is 0, it seems. Here, not necessary. Electric field between A and B is non-zero. We have done these questions, I believe, no? So let us say some charge is there on B, guys. So what we can write? Potential on B. I can write it as K into, let us say, charge on B divided by, uh, because it is on the surface only, you can take R2, will be equal to minus KQ divided by R1. So what will I get charge on B as? I'll get it as minus Q into R2 divided by R1. This will be the charge on B, guys. Okay. So what they're asking, charge density of A and B are same. I cannot say charge density are same. Let us just go back to that only because just remember the options, guys. Charge density of A and B are same. They have given. Similarly, electric field between A and something they have given. So you can just look at this question. We have done it yesterday. We did the distribution, no? Charge distribution we have done, no? Yesterday. Yes or no, yaar?
Yes.
ఎక్కడ పోయిందిరా క్వశ్చన్ అది? I'm not able to find it. Where is it? Someone asked me, no? Was it yesterday or day before yesterday?
Yesterday.
I don't think we have done this yesterday. I'm not finding it anywhere. Okay, I think it was day before yesterday. One of them has asked the doubt, so I have explained that doubt, I guess. No problem. Okay.
So it was third question.
कहाँ है भाई थर्ड क्वेश्चन तुम्हारा? 1 2 3 वेयर थर्ड क्वेश्चन?
So मतलब इसी के आसपास कहीं पे.
अरे नहीं है भाई, देखा है ना हमने.
Day before yesterday, sir.
वही तो बोल रहा हूँ, आपने पूछा शायद नहीं मेरिया. यू हैव ओनली
Yes,
आस्क्ड,
sir.
नो?
Yes, sir.
हाँ. क्यों यार वैष्णव, आई नो आई हैव मेमोरी लॉस. अभी तुम अब जिद पे लगे हो सर, मुझे तो प्रूव ही करना है गलत हो. हाँ, इज दैट द केस?
So looks
No,
like
sir, no, sir. Right. So let us just see this question, guys. So what is electric field inside A? Can you please tell? Electric field inside A, because it is a shell again, it should be 0. What should be electric field inside B between A and B also? It should be 0 only, guys. Right. So what is the answer now? Directly you can say, if they are asking, if they were asking charge distribution, we could have done this, guys. Because they are not asking charge distribution, directly I can say, now you take any point inside, it is inside the shell, it is inside the first shell as well as inside the second shell. Inside the shell, field should be 0. Yes or no? So the electric field inside point A will be 0. That is correct. Now you take here, is this point, right, is it lying inside B or not? Yes, it is lying inside B. So due to the charge on B, here the field is how much? 0. Okay. But will there be charge on A? So because of A, will there be field or not? Here, see, you take first point. Let us take this point. Roman 1, guys. Okay. First point I have taken. It is lying inside the inner shell. It is also lying inside the outer shell. Inside the shell, field will be 0. So at point 1, due to A, 0. Due to B, 0. Overall also 0. Now, Roman 2 guys. Between A and B. Point 2 is lying outside the inner shell and inside the outer shell. So due to outer shell, here 0. But due to inner shell, because due to inner shell, this point is outside. So there will be electric field due to inner shell. There will not be electric field due to outer shell. So there will be some electric field between A and B, guys. Charge density of A and B are not same, because although if even though they may have same charge, let us take charge here is Q, here it is minus Q, guys. Okay. So even though they may have same charge, because their radii are different, the charge density will not be same. Electric field inside and outside A is 0. Inside it is 0, but outside there will be field due to A, guys. Okay, again, always remember electric field at any point will be vector sum of electric field due to all the charges present in the system. Electric potential at a point will be algebraic sum of potentials due to all the charges present in the system. So this is also wrong statement again. Electric field between A and B is non-zero. Yes, it is correct statement. Electric field between A and B due to B is 0. Due to A is non-zero. Overall also it will be non-zero. Electric field inside and outside B is 0. So here obviously it is 0. It is inside B non-zero we got. Outside B also it will be non-zero only, guys. Okay. So what we can write here, the third option will be correct statement. I hope you understood it. Day before yesterday I have discussed similar type of question again. Next, what they have given is volume charge density has been given. Volume charge density for a solid non-conducting sphere is given. QR divided by pi r power 4. Where r is the distance from center. Magnitude of the electric field at a distance, I, from center of sphere, it seems. What will it be, guys? Again, just now we have seen what is electric field inside non-conducting solid sphere. Is it rho r divided by 3 epsilon naught? Yes. So what we can write? 1 by 3 epsilon naught. What is density given as? Q small r divided by pi r power 4. Okay, this is rho value and into small r. So what I'll get? QR square divided by 3 pi epsilon naught r power 4 I am getting. Yes or no? There is no option. Volume charge density for a solid non-conducting sphere is given as QR. Achha, it is a non-uniform distribution. Sorry guys, it should not be done like this. If it is a uniform distribution, you can do it like this. But as you can see, rho value is changing with r, guys. It's a very good question. So let us do that question, guys. Now, this is something. So you can take some. You can consider this particular question, guys. Array. What happened to this? So it is a non-uniform distribution. It is not a uniformly distributed non-conducting solid sphere. It is a which solid sphere, guys? Non-uniform, non-uniform distributed, non-conducting solid sphere, guys. There's some trouble with this. Okay. Right. So what we will do, because it is non-uniform, guys, what we are going to do is from the center, right, we are going to consider a small element, guys, which will be a hollow sphere. Solid sphere, how is it made up of? Solid sphere is made up of n number of hollow spheres, concentric hollow spheres only or not? So what I will do, I am going to take, array rara way. You are going to take, this is the center, let us say. We are going to take a hollow sphere, guys. I'm just mentioning it something like this. I'm drawing a freehand diagram. You will take a hollow sphere. Let us take it something in this manner, right? Which is at a distance small r. So I will find what will be the charge in this hollow sphere, guys. So here it is at a distance small r, and let us imagine the thickness is how much, beta? The thickness is dr. Okay. So what is rho value given for this? Rho is nothing but charge per unit volume. Yes or no? I'm writing it here. Rho is nothing but for a small element, you can write it as dq divided by dv. Okay. Now hollow sphere, no? So what will I write rho value as? I'll write it as dq divided by what is dv value? Volume can be written as surface into thickness, guys. Surface area into thickness. Surface area of hollow sphere will be 4 pi small r square. And what is thickness, beta? dr. So what will I get dq value as? I'll get it as rho into 4 pi r square dr. What is dq value now? I can write rho into, or rho is anyhow given, no, to us. So what is rho value? Q into small r divided by pi r power 4, 4 pi r square dr you are going to get. What we can cancel out? Pi and pi will get cancelled out. So what is dq value? Here you are going to get it as q into r cube. 4q into r cube divided by r power 4 dr you are going to get, guys. So what they're asking us to find magnitude of electric field at distance L. So I need to find how much charge will be distributed inside that L region sphere, guys. So for that purpose, what I'm going to do, I'm going to perform integration. It's a very good question again. Although such type of questions these days are not being asked in NEET, guys. So you can perform integration here. And what will our limit be? From r is equal to 0 till r is equal to L. So what is the charge stored here? We can write it as 4q divided by r power 4. Integral r cube will be how much, beta? Integral r cube. What is it going to be? It will be r power 4 divided by 4. From where to where? From 0 to L. So 4 and 4 can simply be cancelled out. So what is the charge that I am going to get? You can take it as q dash, guys. So I can write it as q into L power 4 divided by r power 4. You take it as q dash. Okay. Because rho is given in terms of q. If not, you could have taken it in terms of small q. Okay. I think it is giving trouble because lot of questions are there from electrostatics and this board has got already. Please come here. Right. You can take it as q dash. Okay. Or small q you can take. I'm all because I've written q dash already, so I'm writing it as q dash. Now what I'll do is in some sphere of radius L, how much charge do I have? I found out. Yes or no, guys? Did I find out or not? Yes, we have found out. Now, how to find magnitude of electric field? So what we'll do, we'll apply Gauss law here, guys. Right? So Q dash, see total charge stored in sphere of radius L we got, which is Q into L power 4 divided by R power 4. Now what I'll apply? I'll apply Gauss law, guys. Integral E bar dot dA bar will be equal to Q enclosed divided by epsilon naught. Right? At all points on the sphere of length L, electric field strength will be same. So what I can do, integral electric field I can take it outside, Q enclosed divided by epsilon naught. So E into A will be equal to Q enclosed. How much is the charge enclosed? I will write it again. Q enclosed divided by epsilon naught. So electric field into what is the area, beta? You will get it as 4 pi L square. Should be, what is Q enclosed here? Q into L power 4 divided by epsilon naught into R power 4 you will get. Okay. So from this, what is the electric field that we are going to obtain? We will get the electric field as you will get it as Q into L square divided by 4 pi epsilon naught R power 4. It's a very important question, guys. Very good question also. Which distribution it is? It is a non-uniformly distributed solid sphere, non-conducting solid sphere. So whenever non-uniform distributions are given, first of all, you will take a small element, guys. So our answer should be how much here? Second option should be our answer, guys. Q into L square divided by 4 pi epsilon naught r power 4. So what will you do? You will first find out how much charge is present inside a sphere or till a sphere of radius L. Then I'm going to apply Gauss law in order to find the electric field. Did you understand, all of you? Do you understand, everyone? How many more are there here in this? We'll come from the back, guys. Okay. The variation of electric field they are asking for a charged conducting sphere. So I have just now told you conducting sphere means inside the conductor what will be field? Inside the conductor field will be 0. And outside how much is it going to be? It will be varying as a point charge. KQ divided by R square, guys. Clear? So out inside it is 0, outside it is varying as square hyperbola beta. So what will be the correct answer for us? What would be the correct answer? Second one will be wrong. Second one will be the answer for you can consider for non-conducting solid sphere. Okay, they are not asking magnitude, guys. If they are asking magnitude for non-conducting solid sphere, third one will be correct. But what they are asking now, they are asking us to find what would be the electric field variation for a conducting solid sphere. So where will the charge be distributed? Will the charge be distributed on the conductor in the conductor on the surface or not, guys? So the whole charge will be distributed on the surface. So inside how much will be the field beta? Inside means from here to here and from here to here. I'll assume this to be center beta. This is taken as 0, 0. So this is taken as how much beta? 0, 0. This will become r, 0. This will be minus r, 0. Now you see towards the right side. See, due to a positive charge, if I'm taking a positively charged conducting solid sphere, field lines will be radially outward. Yes or no? So on this side, field will be like this beta. It will be directed towards positive side. Till here, no field. Above this, you are going to have directed towards positive side. In the same manner, till here, no field. And where will the field be directed? Along negative side, guys. Negative field should be taken as negative again. So towards positive side, it will be positive. Towards negative side, it will be negative, guys. So which variation will be correct? Fourth variation will be correct. However, magnitude of electric field, if they are asking, first variation. Second one will be for non-conducting solid sphere. This is for what beta? This is for electric field vector non-conducting solid sphere. What will be for third one? Third one will be magnitude of electric field for non-conducting solid sphere. This will be electric field for conducting solid sphere. This will be the variation for magnitude of electric field for conducting solid sphere. Clear, all of you? Understood? Electric field variation for non-conducting solid sphere. Electric field variation for conducting solid sphere only magnitude. Electric field variation non-conducting solid sphere only magnitude. Electric field variation for a conducting solid sphere. Understood, everyone? Yes or no, yaar? I hope it is clear. Right? Let us move to the next question, beta. What is given? Potential is varying as potential they have said is varying with all x, y, and z. The magnitude of electric field at 0, 2, 1. As I've already told you, whenever potential is varying with all x, y, and z, what will I write, beta? Minus of dou v by dou x I cap plus dou v by dou y j cap plus dou v by dou z k cap. Yes or no, everyone? Now, when I am doing partial differentiation with respect to x, only x will be considered as variable. Rest all should be considered as constants. So what I'll do, if I do partial derivation of this, y square derivative with respect to x, 0. Z cube derivative will also be 0. What will be derivative of minus x square beta? You will get it as minus 2x I cap plus. What will be derivative of y square? You will get it as minus 2y j cap. What will be derivative of z square here? You will get it as minus 3z square k cap. Is that clear, all of you? This is our electric field now. So what is the electric field that I am going to get? Minus into minus will be anyhow plus 2x I cap plus 2y j cap plus 3z square k cap. They're asking us to find electric field at 0, 2, 1. So if you substitute 0, you will get 0 I cap plus 4j cap plus 3k cap. So what will be the magnitude of the electric field beta at 0, 2, 1? It will be under root of 0 square plus 4 square plus 3 square. 4 and 3 will be Pythagorean triplet. You will get it as 5 Newton per coulomb. Clear, everyone? Understood, everyone? Again, this is the relation between electric field and potential. When potential is varying with all x, y, and z. So how do you do partial differentiation with respect to x? You will take only x as variable. Y and z will be constants. So derivative of x square will be 2x. Derivative of y square and z cube will be 0. How will you differentiation with respect to y? Only y should be variable. It means derivative of x square 0, z cube 0, y square derivative will be 2y. What will be partial derivative with respect to z? It means only z is variable. So x square derivative 0, y square derivative 0, z cube derivative will get it as 3z square. And minus sign is there anyhow before, so I wrote it as minus 3z square. Did you understand? अरे हाँ या ना बच्चा लोग?
Yes, sir.
It's a good question again. Let's see the next question, beta. Charges plus q and minus q are placed at point A and B respectively. 2q and minus q, which are at a distance 2l distance apart. Okay, respectively, which are at a distance 2l apart, it seems. So from A to B, what is separation beta? 2l. C is the midpoint between A and B. So it means from here to here it is L only. And from here to here also it is L only. What are they asking? Work done in moving a charge minus Q along the path C, E, D. Now, first let us see. First things first, second thing second. So A, C, B. This is the original situation. Here you have 2Q. Here you have minus Q. Here you have minus Q. Okay. Clear, all of you? So what is separation beta? Between these charges, as you can see, between A and B, separation is clearly mentioned that it is how much? 2L. And C is the midpoint has been given. So will this be L and will this be L or not? You have how many charges, beta? You have 3 charges. So how many pairs of potential energy will be there? You are going to have 3 into 3 minus 1 by 2 pairs, which is 3 pairs again. So what is the initial potential energy? Can you please tell? Initially between these two, what will I get? K into 2Q into minus Q divided by L. Okay. Plus. Alright, I'll write it with another color because below also you have white only. What is initial potential energy when it is at C? Okay. First two pairs, this. First pair is this. Second pair is this. Third pair is this, guys. So I'll get K into 2Q into minus Q divided by L plus K into minus Q into minus Q divided by L plus K into 2Q into minus Q divided by L. So what will be the initial potential energy? This is anyhow minus 2K small q capital Q by L plus KQ small q capital Q divided by capital Q small q divided by L minus 2K capital Q small q plus K capital Q small q. So what I will get? Minus K capital Q small q by L. This will be minus 2K Q square divided by L. This is initial potential energy. Now what has happened, you see? It is now taken to which point, beta? It is now taken to D point. Okay, finally also we should find this is B, this is D. Right, so 3 charges again we have. Yes or no, beta? We have 3 charges now. So very simple logic. So what is the condition? Here you have how much charge? 2Q charge. Here you have minus Q charge. Here you have minus capital Q charge, guys. Now what is the separation between A and B? This is 2L. Between these two, L. So what is the final potential energy now? Final potential energy will be, again 3 charges you'll have 3 pairs, guys. So I'll take another different color. So what will I get final potential energy in this case? First is between these two. What will I get? K into 2Q minus Q divided by, acha, I did one mistake here. None of you told me, huh? What is separation between A and B, guys? It is 2L. So what will I get here? KQ square by L you will get. Okay. So K into 2Q into minus Q divided by, how much is separation here, beta? 2L. Plus between A and D now. K into 2Q into minus Q divided by 3L, beta. Similarly, between B and D, K into minus small q minus capital Q divided by L. So overall, what will you get final value as? This is anyhow minus KQ square divided by L. What will this be? Minus 2 by 3 plus 1. Minus 2 by 3. 1 minus 2 by 3 will be 1 by 3 or not? So I'll get it as a plus of K small q capital Q divided by 3L. Now they are asking what is the work done, guys. So what will be the work done? What work done will be change in potential energy, which is final minus initial. So if you do this minus this, what I'll get? K small q capital Q divided by 3L plus K capital Q small q divided by L, which you will get it as 4 by 3 K capital Q small q divided by L. This should be our answer, guys. So let us search for that. 1 by 4 pi epsilon naught, 4 capital Q small q divided by 3L. First option should be our answer. Understood, everyone? Yes or no? What is work done? It is simply change in potential energy. If 3 charges are there, you are going to have 3 pairs. So initially, when minus capital Q charge is at C, I have found out initial potential energy. When the minus Q charge went to D, I have found out the final potential energy. So what is separation between them, guys? Again, difference between them, you will get it as 4 by 3 K capital Q small q by L, which is first option. Clear, all of you? Yes or no? Understood? Right. We
Yes,
have 2
sir.
more questions pending. Let us do those questions, guys. Right. 2 identical capacitors A and B are shown in figure. Okay. If dielectric slab of dielectric constant is slipped between the plates of the capacitor B, what will happen to the energy of capacitor B? Okay, please try to understand what will happen to the energy of capacitor B, they are saying. So initially this has capacitance how much? C. Initially this also has capacitance how much, beta? C. Both have identical capacitors, so V potential difference will get equally distributed. So here you are going to get it as V by 2, and across this, initially I am saying, across this also you'll get it as V by 2. Okay. Now as soon as the dielectric is placed, let us say this is our first capacitor, this is our second capacitor. As soon as dielectric is filled, beta, C1 will remain C only. But what will happen to C2? Will it become K times of C? Now, in both the cases, charge given by the battery is same. Let us say charge is what? Same. They are asking us what will happen to the energy of capacitor B, guys. See, it is connected to some potential difference and uh, dielectric is inserted. We have done this question again. When it is connected to battery and dielectric is inserted, what will happen? Energy will become more, guys. It will become K times or not. We have seen that, no, everyone? Yes or no, yaar? Here only capacitance will change. Will potential difference change? No, potential difference is not going to change, guys. So what will be the new energy now? The energy of capacitor B, if you talk about, it will be half into C2 dash into, what is the potential difference across it? V by 2 whole square. So energy will become K times, you can say, guys. We have done this or not, everyone? We have seen this concept, no? Whenever capacitor is connected to battery and dielectric is inserted between the plates, what is going to happen? Capacitance will increase, charge will decrease, potential difference will remain same. Yes or no? Charge is decreasing, capacitance will increase, and energy also will decrease, guys. By K times it will decrease. Okay. So two identical capacitors A and B are shown in the figure. If a dielectric slab of dielectric constant is slipped between the plates of capacitor B, the energy of the capacitor B they are asking. Okay. However, if you want initially, again if I write initially C2 is also C only, what is C effective, beta? C effective. How much will C effective be? Because they both are in series, it is C by 2. Yes or no? Now you find out what is the charge again. It is connected to anyhow V potential only. So initially charge will be how much beta? C effective into V, which we can write it as CV divided by 2. This is first case. In second case, C1 will be C only. But what is C2 now? It will become K times of C or not? So what will effective capacitance be? Can you say, because they both are in series, I'll get it as K divided by K plus 1 into C. Now please tell me, okay, K value usually is more than 1, guys. So what will you get here? 1 by 1 plus K you will get, which will be, okay, okay, whatever its value is. Now what will be the new charge now? This is new C effective, potential difference anyhow same only. I'll get it as KCV divided by K plus 1. This is the new charge now. Will charge stored remain same or not? Yes, charge stored will remain same. So what will be the new energy in B beta? Can I write Q square divided by 2C? So what I'll get? KCV divided by K plus 1 whole square. This is the new charge divided by 2 into what is the new capacitance, guys? K times of C you will get. This is the new energy now. So what will new energy be? I can write it as C and C will get cancelled out. K square, K also will get cancelled out. So I'll get it as K into CV square divided by 2 into K plus 1 whole square. Initially, what will it be? Initially, UB if I take. Charge is how much initially? CV by 2. Right? So what I will get? Half into capacitance is how much beta? Q square divided by 2C you can write. So C square V square by 4 you will get, guys, here. Initial energy I am writing. So UB value will be CV divided by 2 whole square. Half CV square no, divided by, or Q square by 2C you can write, divided by 2C. So what is the initial energy that we are going to get? You will get it as 1 by 8 CV square. Now what will this value be, they are asking. Okay, it depends on, overall it depends on K only, guys, again. So what we can tell regarding this? Although we can say it is increasing directly, but let us just do it something like this. I'll write it as 1 by 4 half CV square, guys. And I'll write this as half CV square. I'll write anyhow as it is. But in place of 1 by 4, I'll get K divided by K plus 1 whole square. Okay. Let us say K value is 2. Because K value will be usually greater than 1 only, guys. Let us say K value is 2. Just for example. So what will I get here now? You will get K plus 1 square will be obviously greater than K only or not, guys? K plus 1, will it be greater than K? Yes. So K plus 1 whole square will also be greater than K. So this value overall will be less than 1. How much less, we don't know. Yes or no? So it depends, again, depends on the value of K. But in general, if I take, right, what will happen in general? Energy will decrease, guys. Okay. But overall, it depends on the value of K again. How much is the capacitance? Two identical capacitors A and B are shown in the figure. If a dielectric slab of dielectric constant K is slipped between the plates of capacitor B, what will happen to the energy of capacitor B, they are asking. So initially effective capacitance is C by 2, charge will be CV by 2. So initial energy is what we can write, 1 by 8 CV square with B, guys. Now effective capacitance is K into K plus 1, K divided by K plus 1 into C. So the total potential charge stored is KCV divided by K plus 1. So what is the energy stored in B now? You are going to get it as KCV square divided by 2 into K plus 1 square. So it all depends on this value, K plus 1 square by K. So let us just see on an average, if I talk about what will this value be, you will get it as K plus 1 whole square divided by K. How much is this value? If this value is more than 4, then you can consider the energy will decrease. If this value is less than 4, then I can say energy will increase, guys. So basically K plus 1 whole square is there. How can I write this? Okay, you keep this question aside, but as per my knowledge, the answer should be decreasing only, because we have seen that again. Potential difference, whenever battery is connected, dielectric is being inserted, energy stored in the capacitor will decrease by k times. So anyhow, I'll just cross verify this question once again, guys. Let us see one more question. In the circuit shown in the figure, charge stored in the 2 microfarad capacitor they are asking. Okay. On applying a potential difference 60 volt between A and B, they are asking, guys. So what we will search for here is, we'll search whether there is a Wheatstone bridge or not here. So I'll just take this diagram below, guys. 1, 2, 4, 3, 6, 8. Okay. So I'll just take this diagram below somewhere and we'll just do the question. They're asking us to find charge stored in 2 microfarad or 4 microfarad. They're asking us to find in 2 microfarad. 1, 2, 3, 4, 6, 8. Okay. So it is something like this, guys. The network is given like this, if I'm not wrong. Here you have 1, here you have 2, here you have 4, here you have 8, here you have 6, and you have B somewhere over here, and between them I think you have been given 3 microfarad, guys. Am I right? This is B, this is A. So here you have 1 microfarad, this will be 2 microfarad, this is 4 microfarad, this is 3 microfarad, this is 6 microfarad, and similarly this is 8 microfarad. So let us talk about this part, guys. So I'll name this as some points, I'll name them 1, 2, 3, and 4. I'll bring it outside just for easily understanding. Right, so I can take it something like this or not. 1, 2, 3, and 4. And between 2 and 4, I have something like this. So this is 0.1, this is 0.2, this is 0.3, this is 0.4. What are the capacities, beta? You have 2 microfarad, you have 6 microfarad, you have 8 microfarad, you have 4 microfarad, you have 3 microfarad. Now please see in this situation, is it forming a Wheatstone bridge, beta? Is it forming a balanced Wheatstone bridge? You can see here. Yes or no? Yes, no. Just tell. This we are getting 1 by 2. This we are getting how much? 3 by 4. So it is not forming a balanced Wheatstone bridge. Is it forming? Yes or no, yaar? Let me just cross check the circuit diagram once again.
Sir, 2 and 1 will be in parallel.
We will do that. I'm just checking whether it is forming Wheatstone bridge or not. 2, 4, 6, and 8 are given. 3 is given in between, guys. Okay. We can keep it aside now. So as you can see, if I have taken it aside, is it forming a Wheatstone bridge, guys? You can clearly see that it is not forming a Wheatstone bridge. So then we will generally solve this question, guys. So how we'll solve is, as you can see, between this point and this point, is there any element? No. So directly I can take and keep this point somewhere over here. So 1 microfarad is connected between here, 2 microfarad is connected between these 2 points. Yes or no? So if I redraw our circuit, so it is not forming any Wheatstone bridge, guys. So I'm not taking this. I'll remove this part. So what we can take, if I redraw this, you will get 2 microfarad something in this manner, and you will get 1 microfarad something in this manner. So they both are forming. You have 4 microfarad over here, and you have 3 microfarad over here. You have 8 microfarad over here. You have 6 microfarad over here. Okay. So 2 microfarad and 1 microfarad will be in parallel combination. So now I think you may get a Wheatstone bridge after you take it like this. So here this point is A and this point is B. Right. So this is given as 4 microfarad. This is 3 microfarad. This is 6 microfarad. And this is 8 microfarad. Okay. So 2 and these two guys, will they be in parallel? They both are connected between two same points. So 1 and 2 microfarad will be in parallel. So I can now replace this circuit something in this manner. I can replace this circuit something in this manner, guys. So I'm going to have 3 microfarad over here. I will have 4 microfarad over here. Between these 2 points, I am going to have 3 microfarad. Again, between these 2 points, I will have 6 microfarad. Between these 2 points, I am going to have 8 microfarad, guys. Yes or no? So this is point A. This is point B. Okay. So over here, this is 3 microfarad now. This is how much? 4 microfarad. This is 6 microfarad. This is also how much beta? 8 microfarad. And this is 3 microfarad. So now you see, is there a Wheatstone bridge? You can see 3 by 4. This 2 ratio also will be 3 by 4. So what we can do, we can simply remove this capacitor. Now 3, 6 will be in 3, 6 will be in series. So I'll get 18 by 9, 2 microfarad. 4, 8 will also be in series. You will get 32 by 12, guys. So I can take overall, I'm going to get some capacitors like this. 3, 6 in series, 4, 8 in series. This is A, this is B. 3 and 6 in series will be 18 by 9, which is 2 microfarad. 4 and 8 in series will be 32 by 12, I guess, which you will get it as 16 divided by, sorry, 32 by 12, no? Will you get 8 by 3 or not again? You will get it as 8 by 3 microfarad. Now, will these both be in parallel or not? So, because they both are in parallel, what will C effective value be? It will be 2 plus 8 by 3, guys, which I'll get it as 14 by 3 microfarad. So, what is the total charge? No, potential difference I think was given as 60 volt. So, C effective into V we can write 14 by 3 into 60. So you will get it the total charge as 31320 is at 280 microcoulomb is the total charge coming out from the battery, guys. They are asking, I don't think they have asked us the total charge. They have asked us in the circuit shown the charge stored in 2 microfarad capacitor, right? So what we can do is they are asking us to find effective capacitance between A and B. So what is the first thing that we will do, beta? Between A and B, I'm going to connect a battery. Now what we are going to get, as I found out the total charge. So from here I am going to get how much charge? 280 microcoulomb. Now this charge will get divided, beta. So it will get divided. See, I'll go in reverse manner. We have taken the diagram now. We are going to go in reverse manner now. Right. So from here we got how much charge, beta? From here we got 280 microcoulomb. Yes or no? From here, arey rara wow. Arey? What happened here? From here we got 280 microcoulomb or not? Now, this 280 microcoulomb, will it get divided in parallel combination you have? So in parallel combination, potential difference will remain same. How will charge get divided, beta? In the ratio of their capacities. So how much will be the charge? Let us say here you have Q1, here you have Q2. So what will be the effective capacitance, beta? If you can see, what is the charge if I want to find out? So Q1 value will be 280 into 2 divided by, what is the effective capacitance we got? 14 divided by 3. C1 plus C2 we got 14 divided by 3. So how much will this be? 2 ones, 2 sevens, 7 ones, 740 you will get, 120 you will get, guys. So through this you will have 120 microcoulomb. So from here you have how much, beta? Q1 we got 120. So automatically what will Q2 value be? Q2 value will be 160 microcoulomb. Now how did you get this 2 microfarad? It was combination of 3 microfarad and 6 microfarad. So what I can say, from this you will have 120 microcoulomb, and from this you are going to have 160 microcoulomb. So charge stored in 4 microfarad and 8 microfarad will be 160. Charge stored in 6 microfarad will be 120. We didn't have any 3 microfarad capacitor. You had one 3 microfarad capacitor, but that was gone, guys, anyhow. Now, how did we get that 3 microfarad? We got 3 microfarad by parallel combination of 1 and 2 or not? Yes or no, guys? We got it by parallel combination of 1 and 2. So how we can do that now? Now what I'll do is, again, parallel combination we'll use. What is that combination? 1 microfarad you can take here, 2 microfarad you can take here. How much charge is flowing into them? Into them we have 120 microcoulomb, guys. So how will charge get divided? Again, in the ratio of their capacities. They are asking charge stored in 2 microfarad. Let us say small q is the charge stored, guys. So what will small q be? It will be 120 into 2 divided by 3, which you will get it as 340. I think 80 microcoulomb you will get. Clear, all of you? So charge stored in 2 microfarad capacitor will be 80 microcoulomb, guys. What will be charge stored in 1 microfarad? How much will it be? It will be 40 microcoulomb. What will be charge stored in 6 microfarad? 120 microcoulomb. What is charge stored in 4 and 8 microfarad? 160 microcoulomb. What is the charge stored in 3 microfarad? Actual 3 microfarad. How much is the charge stored in 3 microfarad, guys? 0, because it is being removed again. This is how we do charge distribution in case of capacitors, guys. Clear, everyone? Yes or no, all of you? Is it clear?
Yes.
These were the questions. We also have few more questions, not few more, guys. A lot more questions in electrostatics are there. Overall, you will get around 3 to 4 questions from this electrostatics, right? Few questions only we have discussed, and majority of the questions were, I think, based on potential and capacitance rather than electric charges and fields. We had only few questions from electric charges and fields. The same will happen in final exam also, guys. You will have less questions from electric charges and fields, more questions from electric potential and capacitance in final exam. If two are asked from electric potential and capacitance, one will be asked from electric charges and fields. Okay. Again, we cannot say anything can happen in the final exam. So on an average, you can consider around 3 to 4 questions will be asked from electrostatics, guys. Okay. So whenever, if time permits, we can discuss the other set of questions also. But as of now, we will end electrostatics here. Okay. So I still remember which questions are pending. Wave optics, some questions are pending, guys, maybe 10, 12 questions. And electrostatics, a set of questions are pending. So whenever we find time, again, it is impossible to find time, guys, but it is only possible if we take out time from our busy schedules. So I will be willing to take out time from my busy schedule. I hope that you also will be able to take out some time. uh, Again, you have 24 hours, I have 24 hours, everyone has 24 hours only, guys. So whatever maximum things we are trying to get an output, we should do that in 24 hours only. We cannot add another 6 hours or 8 hours to a day. For everyone it is 24 hours. For all the aspirants it is 24 hours. This year to, it has break records, I guess. Around 21 lakh people have applied, guys. Usually it will be 16 to 18 lakh, but this time 21 lakh people have applied for NEET examination. So please understand, obviously your competition will increase again. Usually it will be around 16 to 18 lakh, guys. This time it was last year I think 18 it was, before that it was 16, right? This year I think near about 21 lakh odd people have applied. So please be very careful with that. Your competition is also increased now, right? So please ensure that your preparation is up to the mark. Forget about competition. They will be doing their things. You should be doing your things in a well focused manner, guys. Clear, all of you? We'll start current electricity tomorrow. Hopefully if we can take 2 classes. I think I've allotted 2 classes for current electricity. So if you people can give me a 3-hour session, then I can discuss current electricity in detail. I can close that, and you will be able to write a test maybe till Monday morning. The test I'll directly share with your email ID. Whenever test is there, I'll share it directly to your email ID. So suppose today after the class you're writing the test, till tomorrow morning or tomorrow afternoon I'll keep it active, right? Till that time you will get access, but after that, after the paper is discussed, then you will get the total access of the paper. Okay. So that's it from my end for today. We will be meeting tomorrow. As you can see, there are few more questions, guys. Not few, lot more questions are there, but I think you will be able to solve some of them. Some of them are direct questions which we have done again, as I'm able to see some questions here, guys. So I think you will be able to solve some questions from these guys directly, and rest of the questions so anyhow should be discussed again. So my intention will be to discuss these set of questions hopefully some or the other time. Okay, I'll spare time guys, don't worry about that. So please remember, in wave optics we are left out with 10-12 questions that I'll complete. Electrostatics, one class 4 is left out, that we will do. So current electricity, let me take 2 classes and let me discuss the questions guys. Okay, questions, as well as first of all I'll give anyhow review and later I'll discuss the questions. Okay, clear all of you?
Sir,
जी सर बताइए,
sir, doubt.
पूछिए.
So when we are having a conductor, we are saying that there are no charges present inside the conductor, and hence there is no electric field. But inside it is written that what happens is the charges, they arrange them on the surface whenever we are giving some charge.
I never said that there is no charge inside the conductor. I said that in order to make the field inside the conductor zero, charges are going to get distributed on the surface.
Yes, sir. So does that happens only when there is an external electric field, or does it happens usually also when there is a
No, general isolated conductor also you take the charges on the surface only.
So, but
Right.
NCERT has written that, I mean, whenever we are having extra electric field, because of that, they eventually arrange them onto the surfaces.
No, that is a different scenario again. That is induction of charge again. We are not talking about induction of charge. I am talking about an isolated conductor.
So
See, if you take an uncharged conductor, uncharged means there is no charge, but there are charged particles. Yes or no? So in the presence of external electric field, those negative charge particles and positive charge particles, they will arrange themselves in the presence of external field. But if I don't have any external field, I have only an isolated conductor. Whatever charge is there to that conductor, it will be distributed on the surface. If we talk about an uncharged conductor in the presence of external field, then charge will get distributed on the surface. That is induction of charge, induced charges again. But in the absence of electric field, if you have a charged conductor, then the charge of that whole conductor will be distributed on the surface.
whatever charge is present inside it,
What?
whatever charge is present inside it, that will get arranged.
That is a charged. You have two types again. Charged conductor is there, uncharged conductor is there. So whenever you take a isolated charged conductor, when I say isolated is absence of electric field. So for an isolated charged conductor, charge will be there only on the surface. For an uncharged conductor means charge is zero. So there will be equal number of positive and negative charges. So when you place an external field, then depending on whether it is a positive or negative charge will get aligned opposite direction of electric field, positive charges will get aligned in the direction of electric field. That distribution will take place in the presence of external field.
What if I'm giving some charge onto the surface? I mean, will it?
That will be there on the surface only. It will not get distributed inside.
Okay. Yes.
If you give a charge, right, and when you are applying an external field, right, let us say you are giving a positive charge, it means there are negative charges also, there are positive charges also. Negative charge number is less, positive charge number is more. So in the presence of external field, the negative charges will get directed opposite to the direction of electric field, and positive charges will move on the other side of the electric field.
Yes, sir, clear.
Right. Chalo guys. So that's it from my end. We will meet tomorrow. Let us take a 3-hour session tomorrow, guys. Hopefully, and we can complete the current electricity part also, so that you can write the test on Monday again. Okay.